This is a 2024 paper with the mouth as a site of COVID infection, where the detection of viral genetic material in saliva allows for widespread surveillance testing and emphasizes the importance of viral transmission shed through saliva. This has a couple-fold implications as we've talked about prior. The first being that you can get COVID by kissing someone, by sharing a drink with someone, or any other activity that shares saliva between individuals outside of making out with a stranger. This could include things like sharing a drink in a bar, trying someone else's drink after they already tried it, or even for like high school sport teams, a lot of times we shared water bottles, especially during hockey. So making sure that each of the players have their own individual water bottles and that the players don't share amongst themselves. The second is we have to consider things like food preparation and self-serve, like in restaurants, or even at the grocery store, like those self-serve soups. And the third, this is part of the reason why people even thought to do like the combined cheek, back of the tongue, and nose swabbing, and why that's now the recommended method for collecting samples for rapid antigen testing, like on FlowFlex. So it's important to note that COVID can enter and replicate in the oral cavity and then also spread between individuals via shed saliva. Where we've shown in prior literature reviews that oral tissues like the buccal mucosa, the tongue, and the salivary glands can support COVID infection. And what's very interesting is that viral persistence and long-term consequences of viral infections in these sites are not well understood, which then raises the question, are these sites for viral persistence? Meaning a couple things, the first being, are these reservoir sites? And then if these are reservoir sites with subsequent infections, is this a place where they can sort of commingle and create new variants and mutations? One of the theories for viral persistence in the mouth is that COVID is infecting the epithelial cells, and because these epithelial cells are continually shed into the oral cavity, it's possible that these infected cells could then be shed into the saliva, serving as both a substrate for infection and as a vehicle for viral spread. And the reason why this is a pretty good hypothesis, a pretty good theory, is that the gingival epithelium of the periodontum was one of the earliest oral sites in which COVID RNA was detected, where the gingival epithelium is that pink layer in our mouths. Evidence that further supports that hypothesis comes from this study where tongue scrapings were taken from patients, tongue scrapings from acutely infected patients, and then mucosal brush biopsies from autopsy tissues, revealing both COVID spike protein RNA, where the virus was localized in the most superficial layers of the epithelium, layers that would be shed into the oral cavity. And another set of studies using salivary gland tissues recovered from acutely infected patients and from autopsies both identified viral RNA at highly similar overall rates in major and minor salivary glands, where not only is there that expression of the ACE2 receptor, but we also have the TMPRSS2 receptor, which are both preferential for COVID binding. Where other studies have still also shown that COVID is prevalent in the oral mucosa, that dorsal tongue, that back of the tongue, as well as present within the salivary glands, where there is evidence that in those locations, COVID is replicating in the tissues of the human oral cavity. Additionally, given the COVID pulmonary vascular symptoms, the lung issues, it has been proposed that COVID transmits to the lungs via blood vessels in the periodontal packets, and several studies have correlated periodontal disease to severe COVID outcomes, which at minimum provides linking evidence to that theory, meaning that having good oral hygiene practices is going to positively impact your outcomes when it comes to COVID. Interestingly, while there were anti COVID antibodies present in the saliva, they were often non neutralizing, meaning that COVID infection in the oral cavity might be a possible location and place where the virus might be able to persist for an extended period of time, escaping your immune system responses. Some tangential facts that also happen is that several groups have shown a shift in the balance of the oral bacterial microbiome following COVID infection, where several groups have noticed an increase in the abundance of streptococcus in saliva samples from infected individuals. And in a follow up of 122 patients who had been hospitalized with COVID, several had residual oral symptoms an average of 3 months after recovery, including salivary gland ectasia, where the salivary glands appear swollen with no pus leakage, and xerostomia, which is essentially chronic dry mouth where you're not producing enough saliva to wet the mouth. And when you have a dry mouth, this promotes the development of more bacteria in your mouth, in addition to a higher instance of cavities. And recently has been shown that patients with mild symptomatic and asymptomatic infection continue to have increased inflammation in their salivary glands up to 6 months after infection, which is a very long time. Supporting this, studies in murine models recently demonstrated that infection with COVID leads to long-term decreases in salivary flow and an increase in autoantibody production. And these findings are consistent with a phenotype reminiscent of Sjorgen's disease, which is an autoimmune condition characterized by dry mouth, dry eyes, secondary to immune-mediated destruction of salivary and lacrimal glands. So, coupled with the clinical findings of patient reported dry mouth following clearance of COVID, these results suggest that COVID infection has long lasting clinical implications beyond initial infection, which will likely continue to be uncovered in the years following